let's start understanding the code for logistic regression using scikit-learn package again. So you see here that just for time being, you forget about this line. Okay, so you already know about importing a package and how we can import a you know a CSV file or some data file in the data frame. So that is actually exactly I have done here. So if we run this one, it will be imported, and let's see what we have in the data set. We have a data set something like this. Okay, and where you see the outcome is 1 or 0. Remember, you see, just like what I said you, that means it's definitely a classification problem. You cannot say that it's a regression problem, right? So based on this set of input parameters, maybe all these input parameters or maybe some of them, you have to predict what should be the outcome. And outcome can be maybe presence of some disease or something, anything. Now, I'm not interested exactly what this outcome is representing. I'm interested to see how we can proceed further in this case using logistic regression. But before that, what we have done here in this particular cell, if you see that we have just find some feature columns which are responsible for some outcome. So here the total number of columns was 1 2 3 4 5 6 7 8. Here also 1 2 3 4 5 6 7. So that means we have not used one column from the whole data set, and the column is, I think, skin thickness, right? You see the skin thickness is not being used here, but you can use also. Anyway, so first we have decided what will be my x, that is the features, and my y, that is the outcome, right? Now you see, uh, in this side here, one thing I have not done, maybe it's just a simple representation of logistic regression function, so that's why I have not done here. But when you will do, you will start creating model. Maybe you will create some logistic regression model with some another data set, and you will see that there is a lot of different value range, okay, for different uh, features. For example, range of glucose is somewhere in towards 100 and more than that, where BMI is in some decimal. Insulin value ranges a lot from 0 to value towards 100. Diabetes function is somewhere within 0 to very small value actually. So naturally, all I hope that the higher values, the features which has higher values, will actually try to dominate the other features which has very lower range. So what is the solution? The solution is we have to standardize, or we have to scale the features. That scaling I have not done here. What basically I have done in my linear regression function, already you know that. So you have seen that. So I've not done it here because I just want to show you how I'm writing the code and what's happening behind. So my intention is not to make a very good model. You can do that, definitely. A lot of things you can apply here. Anyway, so this particular line is also very known to you. It's just a train test split, normal train test split, not a stratified. Okay. Then what I have done, I have just like a linear regression here also. In sklearn dot linear model, under this we have a logistic regression class present, okay, where you can initialize the class. You can initialize the class. I mean, you can create an object of this class, not initialize. Create an object of this class with random state 16 by this particular some variable, and it's simply just fit of x train and y train, that's all. And once the fitting will be done, what thing we can do? We can actually try to predict what will be the value of y based on the test data set, right? So let's do one thing. Let's do one by one. So I've done up to this, and then this one is done. Fine. Train test is done. Fine. Now we will go for fitting. So let's fit it. You see, it's completed actually. So it's completed. It's very small data actually. So that's why it's completed. And it came here. So if you run this, it will give some prediction. And if you try to print, you will see that some value. Some value means, you see, all are either 1 or 0. See, not any other values, because we are going to predict either 1 or 0. Classification problem. Anyway, so let's further proceed. Now here something that I will show you that we already have learned as a theory in our previous classes, that is how to check the accuracy of the model. I hope you can recall that the accuracy of the model can be represented in a different way, like for example precision, recall, confusion matrix, accuracy, and many more, like, right? So let's do one thing here. This is a way by which you can create a confusion matrix. Okay, by which you can create a confusion matrix. So what is this? For this we have to import another another function class over here, matrix, under sklearn package. Okay, so which is basically you can call this confusion matrix function under this particular class, where you will have to pass what prediction you have done, that is y pred, and y test, that is the test output, the actual output of the test data set, and it will compare, and it will basically show a confusion matrix. So just I'm incrementing a bit so that you can easily see this. And if I just try to run this particular cell, you see what is getting. You are getting a 2 by 2 matrix, and I think you can understand what exactly 2 by 2 means. This is, I hope you can remember, this is representing actual true versus predicted true, and this is what you are representing, actual false versus predicted false. And if you can recall, this side and this side are actually shows the error, right? That say for example this one we call the type 1 error, if you can recall, right? That is, the predicted outcome is true but they are false actually. I'm sorry, not this one, this one. Predicted outcome is true, this one, right? These are, no, I have a mistake. Predicted outcome is true, yes, this one. Predicted outcome is true and actually it should be false. So this is representing type. So I have 25 cases having type 1 error and 10 cases having type 2 error. So obviously I will expect that I will have very large value for these two sides and very small value for these two sides, right? Which is a confusion matrix. In other way, there is one more way by which you can go for a confusion matrix without diabetes and with diabetes. Over here specially, that is something like this, where it shows, you see, the F1 score, recall, precision, and everything. Okay, so I'm not going to going to present what exactly precision and recall is. You can The video is there in YouTube, and you can simply go back. If you cannot recall right now, you can check and you can come back here. So so this is just I have shown you to I'm showing you this code just to show you that how you can use all these functions for your purpose. Okay. Similarly, there is one more very important thing I hope you can recall, that was area under curve, area under ROC curve, right? Area under ROC curve, and this is a very simple code for this. So, and what is ROC? The theory behind the ROC curve creation, again, I have already described in my previous classes. So definitely, I'm not going to, describe over here. You can, if you cannot recall right now, you can go back again. You can check and you can come back here. But just for timing, if I just run this code, you see what will happen. It will basically show a curve something like this. What we have seen when we discussed about this ROC curve, where it is representing the AUC score is 0.88. It does not mean accuracy is 88%. Don't think. The AUC is a different calculation, you know that already we have discussed. But one thing you can say, that AUC is 0.88 means towards 1. The value of AUC always lie between 0 and 1. So as good your model is, this AUC value will increase. So that means the area under the curve is representing 0.88. So it's a pretty good model, and definitely it will be much more better if the AUC value increases and touches, go tends to 1. Okay. So this is the very simple code that we have discussed for logistic regression, where you can see various outputs. You can check how good your model is. So this is all about the logistic regression. Okay. So we have discussed about the maths and the theory of logistic regression, as well as we have also seen some levels of Python code. So now what we can do, we can go back to the presentation again, and we can further proceed to the next algorithm, which is what we call k nearest neighbor algorithm. Let's start.